what we want to do is to look at correlation, basically. But along the line, we will look at visualization and descriptive statistics. Take note. So we all do projects, we all do theses, we all do dissertations, we all do research. We sometimes even write project reports for managers. And we always sometimes look at association between two or more variables. For example, we look at the relationship between the blood pressure and the weight of a person. And sometimes we wonder whether other factors are causing the blood pressure to go up instead of just the weight. You may think that a person has a bigger weight and that is what is increasing, but behind the scenes, the age, the stress, the diet, the exercise, all of these are involved. What assumption must be in place before you can even assume that weight affects blood pressure? So the essence of this is to look at association, correlation, causality, regression. Okay. Who can tell me this? What do you think is the relationship between consumption and income? Is it positive or negative? Consumption and income. Is it po or ne? Yes, Blaston.
Hello, Doc, please. I think it's positive.
What about CSR and performance? What about CSR and performance? Yes, Blaston.
Doc, it's also positively, there's a positive correlation between them.
So these are the general idea, general notion of all of these. Okay. So what we want to do first is to look at association. And in numerical analysis, there are two ways of measuring association. One is by using covariance, the other is by using correlation. What is the difference? They all measure relationship. They all measure nexus. They all measure association. Covariance, the range is between negative infinity to positive infinity. That's covariance. Regression, correlation, the gap is between -1 and +1. What is the problem with covariance? The problem with covariance is that, of course, a positive value will indicate that there's a positive relationship. A negative value will indicate that it's a negative relationship. It tells you that it's positive or negative, but it doesn't tell you the strength. It doesn't tell you the strength of the relationship. It's very hard to explain the magnitude of the relationship. For example, if you have a larger value, it doesn't mean that the relationship is stronger. Why? Because correlation depends on the unit of measurement. So the unit of measurement matters a lot, but covariance depends on the unit of measurement. But correlation does not depend on the unit of measurement. So one can be in kilograms, the other can be in dollars. And correlation will still tell you the relationship. And correlation is the positive one. The positive correlation is between 0 and 1. And anytime something is between 0 and 1, it is a percentage. Covariance, the positive one is between 0 and infinity. And anytime something is between 0 and infinity, is not a percentage. And so you cannot tell that one is better than the other, or these are better than that, because you don't have a limit. Because infinity is an unlimited positivity. So correlation looks at both magnitude and direction. That is why I always like to use correlation, even though you can use covariance. There are some situations, especially situations related to factor analysis, principal component analysis, where you might need covariance. but correlation always wins. Hope you understand that. Now let's move on. Let's look at, so now that we know correlation always wins, it means that we can measure the strength of a correlation. What do you think is the relationship between a brother and a sister? And then between cousins? What do you think? Is it strong or weak or strong? A brother and a sister. What do you think? The correlation between a brother and a sister. Samson.
I think it's strong because they are of the same parents.
What about cousins?
I think cousin will be weak because of the distance between the parents.
Good. Now, is it positive or negative or positive? Let's look at it. Correlation can be positive, can also be negative. But please note that positive doesn't mean it's good. And negative doesn't mean it's bad. Let's take a few things. What do you think is the correlation between consumption and income? Positive or negative? Consumption and income. I'm going to call everybody now. Samson Adamilate. I'm going to call everyone here today. Samson Adamilate, tell me.
Doc, it's Samuel.
Samuel Adamilate, tell me your answer.
Doc, it's positive.
Why?
Usually when your income increases, you tend to go for higher costing, or you tend to change your lifestyle to suit the income that you are receiving. So that's why the correlation.
Any reason why you didn't raise your hand to answer?
Pardon?
Any reason why you didn't raise your hand to answer this question?
Oh, you called me. Doc, you called me. That's why.
Yeah, I'm saying that. Why didn't you raise your hand?
Oh, you just asked the question. I was motioning towards the reaction to raise my hand.
So you would have raised your hand to answer?
Yes, please. I would have.
Oh, wow. Okay.
Yeah.
Very good.
Thank you.
Let's go to the next question. The price and quantity demanded. What is the relationship between price and quantity demanded? Samuel Larry. Samuel Larry.
Doc, it's positive.
Explain.
Because price and quantity demanded. If the price is high, the demand will be low. And if the price is low, the demand will be high.
And that is what relationship?
That will be negative rather, not positive, negative.
You know, my next question I asked you was to help you to think. You know, you weren't paying attention. I will call everyone, so everyone must be ready. Pay attention. This question goes to you, Samson. What is the relationship between GPA and learning hours?
I think the relationship between GPA and learning hours should be a positive one. For the more time you learn, the likelihood of retaining the thing become more probable.
Good. Very good. So let's take a couple more examples to see the bigger picture. Now, Richard Otu. What is the relationship between age and power of vision? Richard Otu. Can someone tell Richard Otu?
Yes.
Go ahead.
Power of vision only as sight. Vision has the ability to see the future. It is sight.
So what is the relationship?
It is sight. It is power of vision.
I'm talking about power of vision is sight. Yes, it's sight. What is the relationship?
Positive.
Positive. Good. It looks like your network wasn't that good. Yes, Derek.
Okay, maybe the answer I'm giving, I don't know. The confusion here is whether it's positive or negative. But I know when you age, your vision either becomes a bit, it becomes weak. But in rare cases, you have people who have their eyes still maintained. So that's where I have the confusion, whether
You
it's...
didn't have a confusion. You were right. He was wrong. Okay. I just have to let him continue.
Okay.
So explain.
Okay, so what I'm thinking is inverse. In the case where as an individual grows, the vision tends to deteriorate.
Exactly. So there's a negative relationship between age and your vision power. Your eyesight falls as you age. It's simple. Guys, pay attention to my class because I will call you and you'll be speaking gibberish if you are not paying attention. Paul Besson, this goes to you. What is the relationship between running time and calories? Paul Besson.
Prof, I'm here.
Guys, I want all of you to pay attention because I'm going to call all of you. So don't wait for me to mention your name twice.
Yeah,
okay.
I'm here. So
I know you are there. So yeah. Go ahead.
Running time and calories burned is a positive relationship.
Why?
Because the more you run, the more calories you burn. So as your running time increases, your calories burned will also increase.
Good. Now let me go to Papa. What is the relationship between temperature and ice cream or bottled water?
Positive correlation.
Why? Papa, why?
Higher ice cream temperature would increase the ice cream and bottled water sales.
Good. Obedaji, what is the relationship between study time and grade?
Doc, and the relationship is positive because the more you study, the higher your chances of getting a good grade.
Very good. Noah. Yes, Benjamin.
So, Doc, Noah here.
Yeah, Akila, so go ahead.
Yes, I partly disagree with the positive correlation between temperature and the ice cream or bottled water sales.
Okay.
The lower the temperature, the higher the sales of ice cream or bottled water sales. Because, I mean, so there's an inverse relationship there.
Why?
So lower temperature, usually people want to drink cold water.
How do you define temperature? Explain what you mean by lower temperature.
So lower temperature is actually
is it
one to the negative.
Which one are you talking about?
It's cold. Lower temperature is cold.
Okay, so you mean when the weather is cold,
yeah,
people want to buy ice cream more?
No, when the product is cold.
No product. We are talking about the weather, temperature.
Okay, the weather. Okay, then I get it now.
All right.
My substantive question. You were going to ask my substantive question.
Yeah, yes. Your substantive question is price and quantity demanded.
So for normal goods, there's an inverse relationship. The higher the price, the lower the quantity demanded.
Very good. Let me go to Nana Boama. Wage and experience.
Yeah, good morning, sir. Probably positive relationship.
Why?
The more experience you have, the more your wages, ideally.
Good. Manaf, consumption and savings.
Well, it's negative. The more you consume, the less you save.
Very good. I agree with all of that. Let me go to Joshua. So guys, you can always have the chance to raise your hand normally, but I'll still finish with this list. You can always have the chance to raise your hand whenever I'm talking and asking you questions, okay? Because you have the capacity to do it. You can do it, so do it. That's the point. The formula for the covariance is this first one here. The formula for the correlation is that one there. The correlation can also use this formula in blue, okay, where the denominator is this one, which is for X, and another one, which is for Y. Now, sometimes when you're writing your paper or your thesis, it's good to bring some of these mathematical formulae and explain them because you are using them anyway. It gives it a bit of a PhD-able, rigor. It shows that you are a bit theoretical and not just always mathematical. It helps your work to be properly, appreciated because you are using it anyway. You are using it. Where you put it is another thing. You can either you put it in the main document or you put it in appendix. It's a whole different ballgame. Okay. Correlation, we've already said that the strength of the correlation matters more than that. Now I'm going to write some numbers here, and then Joshua, you tell me this. Which of these two numbers has a strong correlation? 0.8, negative 0.8, and then 0.75. Well, let me put it this way. Negative 0.8, and then 0.72. Which of this has a strong correlation? Joseph. Joseph, who am I here?
That's a 0.7. Oh, sorry.
Joseph.
Yeah, I said 0.75. Is it 0.7? Because it's closer to 1.
Why? Because it's closer to 1. That is wrong. And you see your colleagues have raised their hand. Of course, I'll ask them why. So let me go to Obed.
Hello, Doc. I would say the 0.8.
Why? It's not 0.8 I've written there. Be clear.
It's negative 0.8.
Why?
It has a stronger one as compared to the 0.72 because when you look at 0.8 is higher than the 0.2, but just that the relation is negative as compared to the other one that is positive.
So it is stronger in what terms? Samson.
It's stronger. Okay.
Hello. So I think the strength of correlation is not determined by the direction, but rather by the magnitude. In this case, we use the absolute figure and not with the negative or positive. So 0.8 is closer to 1 than 0.72.
Very good. So guys, understand these things because they will appear. Multiple of these will appear. Okay, I'm going slower for a reason. Okay, so that is how you can understand the strength of correlation. There are types of correlation. We have the Pearson's product moment, which is when the values are more ratio data. And then we have the Spearman for rank data or for ordinal data type. And also for more ordinal data types, you can use the Kendall rank correlation coefficient. So these are types of correlation coefficient that one can have. Now, there are some misconceptions when it comes to correlation. The first misconception is that strong correlation means, or correlation means causality. Who can give me an example of situation that a person can wrongly assume that correlation means causality? Who can give me an example? This one is open. Who can give me an example? Emmanuel.
Doc, temperature, hot temperature causes ice cream sales increase. This may be tend to mean that as soon as there is a hot temperature, it will cause an increase in the sale of ice cream. And that's an example of such. Say.
But what? You have to tell me about what?
But correlation doesn't mean causality. That a hot temperature will necessarily lead to an increase in sale, but it's just establishing the relationship between the two. Thank you.
Not exactly what that means. We've tried, but not exactly what that means at all. Noah.
Yeah, so Doc, I want to use the issue of income, the relationship between income and savings.
Okay.
So whilst the expectation is that once there should be a positive correlation between increased income and savings, usually it doesn't follow the case. And so your income could be increasing, but your savings not correspondingly increasing.
No, that's not what we mean by confusing correlation with causality. That's not what we mean at all. You guys are missing. Let's see whether another person will come in. Samuel Adamelate.
Hello, Doc. So please, I want to attempt at something. Oftentimes, when temperatures increase, you often realize an increase in the number of houseflies that are in the environment. So usually you would say that yes, houseflies. So usually,
housefly, you mean?
Yes, houseflies.
Okay.
So someone can conclude that
housefly, right?
Yes, the insect housefly.
Okay.
So in that scenario, someone can conclude that higher temperatures, or there's a relationship between higher temperatures and increase in housefly populations, but that would not necessarily be a causality per se, because there could be a host of other factors that could contribute to the increase in houseflies within a particular environment. So I don't know if that would be a good example.
Such as, you say a host of other factors, what such as
environmental cleanliness and all these things, which also contributes to housefly increase. So temperature will not necessarily be the cause, although there's that correlation. It's not necessarily the cause for increase in houseflies within a particular environment.
That's a very good example. Even though there is that correlation, there is not that co-causality. Very good. Very good example. The more examples you guys explain, the better the rest. Let me go to Derek.
Okay, Doc. My example is ice cream sales and then drowning death. So like people drowning. So the fact that when it's hot, people buy ice creams and people decide to go and dip themselves in swimming pools doesn't mean that there's a relationship between ice cream sales and drowning dead bodies or drowning bodies. Okay, let me explain again. So when the temperatures go high, people tend to buy more ice creams. At the same time, you have a lot of people trying to dip themselves in swimming pools or going for a swim. And usually when a lot of people decide to go for swims, there's a high probability of people drowning. So it doesn't mean that the fact that we can't see there's a relationship between ice cream sales and drowning deaths. Are you getting my point?
You know what you're trying to say. Okay, so you've taken 4 variables and combined them. Are you aware?
Yes.
Yeah, you could have taken only 2 and then indicate other factors and then mention that other factors like this is what is causing that. I don't know whether your colleagues understand, but what this guy is saying is that there is a positive correlation between higher sale or higher demand for ice cream and drowning. Okay, as people are buying more ice cream or people are selling more ice cream, drowning is also increasing. They are all increasing, both of them. So because they are all increasing, someone might think that the increase in the ice cream sales is what is causing the drowning, because they have a positive correlation. In fact, some of them can even have 0.9%, 0.90%, 99% correlation. And you'll be tempted to say that, oh, there is a causal relationship between ice cream sales and drowning. But no, the drowning wasn't even caused by the ice cream at all. The drowning was caused by people increasing their swimming capacity. The drowning will be because the temperature is hot. The drowning is happening because the temperature is hot, but not because people are buying the ice cream. But apparently, when the temperature was hot, that has also triggered people to buy ice cream. So even though ice cream sales have gone up and it has a positive relationship with the drowning, it doesn't mean that ice cream is the one causing the drowning to happen, or the drowning is the one causing ice cream to go up. They are all being affected separately by another factor, or even separately by separate factors. And that is a point that I think you are trying to say. Derek, is that a point?
Yes, Doc, that's what I was trying to say.
All right, let's go to Albert.
Yes, Doc, thank you. I think I want to use a very popular one, which is fuel price increases and then exchange rates. We know that in Ghana, when fuel price increases, most of the time it is attributed to the exchange rate, but there could be other factors such as increase of the crude on the world market and other factors that could cause the price to go up.
Good. Very, very good. Guys, let me ask you something. Angie, you have another one to give.
Yes, I wanted to use increase in age and then certain types of cancers. Medically, it's said that as you age, for women, there's a likelihood that you might contract breast cancer or cervical cancer. It's correlation, but not necessarily causality, because there could be other factors like genetics and then lifestyle. I don't know if it's a good example, but that's what I think.
So what you're saying is that because there could be other factors like genetics and lifestyle, it doesn't mean that the age is not causing the cancer. It doesn't mean that the age is not playing a role in causing the cancer.
It's a correlation, but not necessarily cause and effect. It doesn't mean that.
What I mean is that, are you telling me, for example, that will increasing age not cause cancer at all?
There's a likelihood.
If there's a likelihood, yeah, then there is some causality. If there is a likelihood, then there is some causality. And once there is some causality, then there is causality. So you want to give an example that is unrelated, completely unrelated, but they are all moving in the same direction.
Okay.
Or moving in an opposite direction. That's what we mean. Okay. That is why we say that misuses of the term. And a lot of people make that misuse. And I see that a lot, by the way. Okay. So let's take an example. You all know that there are restaurants around and there are markets around. Markets like Agbogboloshi Market or Makola Market. Now, there's this belief that if people love to buy restaurant food, cooked meals food, then the tendency is that they will not do what when it comes to the ordinary market. What is that tendency? If they like to go to a lot of restaurants to buy food to eat, then there's a tendency that they will not do what to a population market. Benjamin.
Meaning they reduce the consumption at Abubushi market. For that matter, people will not buy things from Abubushi markets.
Good. But here is a fact, and this is a fact we have already seen tested. We have seen that there is a positive 0.88 correlation between sales at ordinary markets and sales at a restaurant. There's a very high positive correlation, almost 90%. Does that mean there is some causality there? No. In fact, there is not a single causality. Why? Because we got to realize that as people are going to buy foodstuffs at the ordinary market, it has been their lifestyle to always go buy foodstuffs at the ordinary market. And those that go buy food at a restaurant, it's also been their lifestyle. So they are all increasing. You might think that because people are going to these ordinary markets, then the restaurant should lose demand. No, but they always also get demand because there are people who are constantly patronizing in both angles. And so the two items are all highly correlated, 90%, but they are all being affected by different things. So nothing from this is causing the other, nothing from this is causing the other. Guys, do you get what I mean? Do you get it? And this is high.
Yes, sir.
This is what we mean by high correlation, but no causality. No causality at all. So take note.
Doc,
Yes.
I think you should repeat it again one more time.
So one more time I'm saying is that ordinary market like Makola, people will go and buy. So even when there's, say, Christmas, you know, people have this mentality that during Christmas, people will normally go and buy foodstuff at the Makola, at the ordinary market, normally the day before the Christmas. So most of the time, we think that the restaurant will not even open because people will not go and buy food, isn't it?
Yes.
But on the very evening of that Christmas, even though there has been sales in the Makola section during that week, there will also be higher sales at the restaurant during that week, isn't it?
Yes. Sir.
So both of them, we checked the correlation for sales here and sales there, and they were both high. The correlation was 90%. So you might be thinking that since there's high correlation, then there must be a causality, which means that it is because people are buying things at the Makola. That is why sales have gone up at the restaurant. No. Or it is because sales have gone up at the restaurant. That is why people are buying things at Makola. No. They are all highly correlated with a coefficient of 90%. And yet, nothing from here is causing nothing from here. The people are even unrelated.
Okay. Hello, sir.
Yes.
Yes, another thinking is also coming up. Now, with this example, I'm also looking at it from another angle where, those buying food from the restaurant, those managing the restaurants are also buying the food stuff from the same Mokola market. What happens in terms of that?
That's a very good point. That's a very, very laudable point. Okay. So now, if that is the case, okay, that has not been proven yet, but if that is the case, then that might explain. But again, if that is the case, that might explain why. So let me get this right. If they are buying things from that, then why should people go and buy from them? But again, that is a possibility. That's a very thinking possibility. That the restaurant people are buying their foodstuffs from these people, and that is why. But then still, if they are going to buy this thing from people, people are still buying it from them. So it means that there are still some people who don't go to the market.
Yep. Yes.
There are still people who don't go to the market, but then they buy from the Makola people, from the restaurant. But I'm saying that your point could be a possibility. So, yes.
Okay.
I'm looking at this from, yes, Obri, you have a point. Obri? Obed, sorry.
Yeah. Hello, Doc.
Yeah, go
Please,
ahead.
can we say that the Christmas is actually causing the high sales in both the ordinary market and then the restaurant?
Oh, yes, we can. That week, we can. But what we are not saying is that we are not establishing. So what you just said is that you are establishing a causality between the Christmas and the sales in both markets. Okay? But you are not establishing a causality between the Makola market and the restaurant. That's what we don't want to establish. But your great friend has brought some possible connectivity, which I find that to be interesting, which will be something. That's what we call moderation or interaction. Yes, Adame.
Yes, Israel. So having a bit of knowledge in the hospitality sector, I believe that is indeed the case, that a lot of these hotels, restaurants, they source their produce from Agbobloshi, Makola, and they do this very early at dawn. So there's that connectivity that exists. However, it stands to be proven, but then it is actually the case that these are the things that actually happen. So
yeah, that's a possibility. Okay. But the key point you all can understand here, okay, is that something on the outside. So let me just draw something for all of you to see. Okay, something on the outside. Let's say there's something here which is Y1, and then there is Y2 here. And there's a strong correlation between Y1 and Y2, say 0.9. And yet, Y1 is not causing Y2, Y2 is not causing Y1. Both of them are being affected by X1, or both of them are separately being affected by X0 and X3. That's a possibility. And so there is no causality between Y1 and Y2, but there's a causality between X0 and Y1. And there's a causality between X1 and Y1. And there's a causality between X1 and Y2. And there's a causality between X2 and Y2. But there is no causality between Y1 and Y2. And yet there's a high correlation between Y1 and Y2, just as there's a high correlation between X1 and Y2, X1 and Y1, X0 and Y1, X2 and Y2. Yes, Samuel, your hand is up.
no, Prof. Doc, I forgot to lower it. Sorry.
Okay. So that's it. So just understand that correlation does not imply causality. Another thing is that weak correlation doesn't mean no relationship. So the fact that you have a weak correlation of 0.3, 0.2 doesn't mean that there's no relationship at all. There's something that you got to explore further. Another thing is extreme values, which are also called outliers, can affect correlation coefficients. And you will see this as you go further in this. Okay, now let's take a paper that you are writing, and then let's see the outcome of this paper. You're writing a journal paper. The journal paper is titled Determinants of Demand in the Alcoholic Beverage Industry in Ghana. Now, a lot of people have written papers like that. They've all been writing papers like determinants of demand, determinants of demand, determinants of demand. The problem is that you have identified some research gaps. You have realized that they don't capture location, the impact of location. They always will capture price, price of other goods, population, income, and other things. They'll capture all of this. But you have realized that they don't capture these factors. In fact, you noted that only 6 papers have captured location. No paper have actually captured this. Okay, so even though previous studies have looked at this subject, you wrote that They have not considered the potential effect of location on occupation. Of course, you have to justify this. And then when it comes to religion, you indicated a few studies have considered religion, but they've not included Buddhism. They always look at, Christianity and Islam, but they've not considered Buddhism to the best of your knowledge. So you want to do a beautiful research on this matter. Of course, there are other gaps you may have seen. Okay? For example, say previous studies use only ANOVA, okay, and correlation, but they didn't use regression. Or even if they use regression, they use OLS, they didn't use GMM, generalized least squares, or generalized method of moment, or two-stage least squares. They didn't use any of these. So you want to go for that. So these are possible gaps in your thesis or research you could have identified. So you can see that these gaps I'm talking at the end here are methodological gaps. And the gaps I said in front here are conceptual gaps, okay, or empirical gaps. So note that it's not all the time you can have methodological gaps. You can also have other gaps related to that. Okay, now, question. How do you proceed with this research? From the problem statement, you state your contribution. That's what you normally always have to do. And a lot of students have to learn that, okay? That from the problem statement, you must always state your contribution. What are your contributions? This paper makes a novel empirical contribution, methodological contribution, theoretical contribution, conceptual contribution, and then blah, 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 blah. You state all of that. Great. Now, you have to review the literature. I'm giving you how to go about and eventually come down to our purpose. You have to review the literature, critique previous studies, what they have done, endorse those that have done, and critique what they have done that you didn't do, or what they did wrongly, or what they should have done. You do that. The literature review is not just a summation of a collation of papers, and giving a synopsis of the papers. No. It is for you to be talking about the papers and critiquing them. Bismarck and Johnny in 1999, used a data of 125 firms over the period of 2000 to 2000 and blah, and were able to, estimate the causal relationship between A and B. However, instead of incorporating this, they incorporated that, and they did not capture this. Also, their methodology only acquired or used this and not that. And this gap is filled in the present study. So after you've studied all of these things, you now gather your data to answer your research question. In fact, you can pull out a research question from here. Okay, a question like, does the moderating effect of location and occupation, or the moderation of occupation and location have any impact on the quantity demanded of alcoholic beverage? Okay. Does Buddhism, affect, the demand for alcoholic beverage, blah, blah, blah. You can couch a lot of research questions from this. In order to learn more steps on how to write a journal article, read this paper in MIT. It's a very good paper. That will give you the step-by-step on how to get it. The title is How to Write a Scientific Research Journal Article in a Scientific Journal. Okay, so let's come to our data. Our data is called Brukutu Ventures. It's a local gin distillery. It is concerned about this demand. So the demand has been hit because new entrants have come into the market. And management is concerned. And so you are doing a thesis paper for them. You practicalize the paper for them, but you thesis the paper for your dissertation. So you gather some data. One of the data is the quantity demanded of gin bitters. It is actually your outcome variable. We'll come to that. Another variable, which is not your outcome variable, it's not your dependent variable, but it's rather your independent variable, is price. We'll talk about all this as well. Another variable is complement price of gin. You also have the average real income of the people. Okay. You also have several other things. So look at the data set. I'm sure you all have the data set as well, don't you? I have the data set here. Do you all have the data set?
We have.
Fantastic.
Yeah, Doc, we have.
Today, we are not going to learn too much about this data set. There's a lot to learn later. But today, we just want to look at the correlation within this and why some values you don't need to do correlation. So please note that you have the price, you have the complement price, you have the income, you have the location. Location is a dummy variable, which means that it has levels. Urban, rural, for some of this. And each one of these is a shop. Take note. So you have shop 1, shop 2, shop 3. These far left. They didn't write them, but so when you take the information here, the first information here is for the shop 1. This shop is selling 160 bottles of Brukutu gin bitters. I hope you guys remember the advert for Brukutu. Okay. I don't know if they still play that advert, but you know them.
Yes, sir. We know them, sir.
The people that take this alcoholic beverage, their level of occupations are all here. Their level of occupation is here. Some are teachers, some are fishers, some are traders. And their religious affiliations are here. Some of them are Muslims, some of them are Buddhists, some of them are Christians. And these things you believe can affect their quantity demanded. So you have all of these information here. Now, before you even go to causality, which we'll do next time, you want to look at correlation. But before you even do correlation, remember that the data can be coded. So when you go back to the Excel here, there's another sheet, which I call Brukutu coded. You can see that the first 4 variables are the same as the Brukutu for R here. It's the same 4 variables. But the coded one is for Excel. The R one is for R. So when you're doing the thing in R, it's nice to do this one. Apparently, I've also realized that in Python, you will use the Excel one. Now, how do you code? Let me show you quickly. If you don't understand, please ask. So you first look at the uncoded one, location, for example. You ask yourself, how many levels are here? And you can see that we have 2 levels, urban and rural. By the way, if you are not sure how many levels are there, R can tell you easily. Urban and rural. Then wherever you see urban, so you create a code, a dummy code, and call it location urban. You just choose one. You don't need the others if there are 2 levels. So here, I created a column called location urban, LU. And then you take each of them row by row and ask yourself, the first one, is it urban or is it not urban? If it is urban, give it a value of 1. If it is urban, give it a value of 1. If it is rural, give it a value of 0. If it is urban, 1. Rural, 0. Rural, 0. Rural, 0. Rural, 0. Guys, do you see it? But doing this thing one by one can be a headache. So there's an easy way you can do this in Excel. What you can do is I can take this column here and copy the column. Create a new sheet. Do you see my screen, by the way?
Yes, Doc.
Good.
Yes, Doc.
So you see this new sheet I've created. I have put location, but I'm going to label it as LU. LU. Then you go to Control F. Control F will do search, find. And then select replace. So you choose replace, find and replace. And then you type find what? Under find what? Type urban. See, that's why I've separated the sheet. Type A-U-R-B-A-N, urban. So whatever you see urban, you're going to replace it with 1. So you type 1. You see, urban 1. Now check this column here. The moment I click replace all, everything urban will be replaced by 1. So you have dummy coded it. That is what it means. So watch it here. It's going to change. Once you click all, it will tell me the number it has replaced. It has replaced 20 of them. And you can see that wherever there is urban, you have done that. You are done. Now change the thing to rural and say that wherever you see rural, this time replace it with what? Who can tell me? Replace it with
Zero.
Zero.
So you type 0, and then you do replace all. And now, once you click this, everything has also been replaced. Now you have coded it. You have a beautiful dummy. Now in a code, in a numerical form, even though it's actually not numerical, okay? You have coded it so that you can use it in that capacity. So just understand that this is how you do coding. Now, if it was, and then once you've gotten it here, you can now come and add it here. You can now come and put it here. You don't need to do it in the same sheet, because if you do it in the same sheet, it will rather change this one. Okay. So once you've done that, suppose you are doing religion, because religion has got 3 items. Copy religion like this. And religion has got 3 levels. Okay, 3 levels. So here, when it comes to religion, you have to create 2 dummies. So take it, write it down somewhere. Whenever you have 3 levels, you need to create 2 dummies, because the one you don't create is always the reference category. The one you don't create, the one you don't make a dummy of, is always a reference category. So that means that, for example, so here, the 0 was a reference category, because that is a one that the other one will be mentioning reference to. So whenever I say urban, I'm saying urban with respect to rural. Rural is a dummy. That's the one giving 0. So here, you're going to create a dummy called religion Christian, RC, and then religion Muslim, RM. So you're going to do for each column. So what are you going to do here? You're going to do replace, find and replace again. And then under find and replace, you're going to choose Muslim. Okay, religion Christian means you should start with Christian. So look at the way it is spelled here and spell it the same way. It's not Christian, but it's Christians with plural. So you type Christians, and then you type 1. Okay, but before you do that, let me close it. Before you do that, he's going to put the answers here. So it's better you rather capture this thing, because you have to do it one by one, each one in each sheet. Okay, so just so you know, you have to do it each one in each sheet. So let's call this RC. So you're going to change this whole thing. And then when you are doing the Muslim one, you also do it in a different sheet. Okay, so you do F, and then change Christians to 1. Okay, Christian is going to be 1. Every other thing is going to be 0 for that column. So here you indicate that everything under Christian should be 1. So you click replace all. 12 of them are replaced. Okay, then everything else becomes 0 for that Christian column. So here you go and change and do for Muslims, and then replace Muslim, code it as 0. So everything under Muslim will be 0. Okay, that is also done. Then everything under Buddhist will also be 0. So you type Buddhist for that column, because we are doing Christians. Check spellings all the time. Buddhist is 0, so let's do that. And that's also done. So you can see that in this column here, everything that is Christian is 1. Anything else is 0. You have to create another Excel sheet and say everything that is that is 1. Everything else is 0 for Muslims. and then you make Buddhist your reference category. So you don't do for Buddhist. This is how you do coding. Okay, so let's go back to our data. Now at this stage, we can now do descriptive statistics in Excel. It's very simple. I think I've done it before with you. Okay. If you are using the coded, okay, it's very easy to do descriptive statistics. But remember, descriptive statistics for dummy variable is not necessary. And I see people sometimes do that, it's not necessary. But for this purpose, I'll just do it for, just for some sort of beautification purpose. So you go to Data tab, on the far right, you choose Data Analysis. And then you choose Descriptive Statistics here. If you have your work, you can follow through. If you don't have, you can watch it later. And then you select everything, okay? Everything here, do Control-Shift down, and you highlight everything. Then in the labels here, tick labels in first row. Take the output range where you want your results to be. Click a space to the right of the data set. Let's say column J1. That's where you want your results to be. And select Summary Statistics. It will give you all the summary statistics right now. There you go. Every one of them is given. But you see, they all will have mean, median, none of that. So you want to just move the items one step. So you click on this, all of them, you just move them one step to the right. So you just click the next one and paste all of them. What have you done? What you've done is that now you're going to delete this because they all have the heading. Okay. Delete all of them so that only the numbers will be nicely put. What you are doing here is called descriptive statistics. Now you couldn't do the same thing for the dummy, for the coded, or for the non-coded variables. Okay, so now I can delete. Right click and delete. Everything here will be deleted. And then the whole summary will be nicely put together like you can see here. Now you have your summary looking nice for each variable. So when you look at this column, you see that the mean for quantity is 175, the price is 15, this one is that, this one is that. These are the numerical variables. So they are the most important ones. Okay. Now, the other ones are dummies. And for dummies, obviously it's going to be 0, 1, 0, 1. So you don't need summary statistics for this. You don't need them. They won't make any sense. Okay. Of course, the mode is going to be 1. Of course, the mean is going to be that. So these things don't mean anything at all. But the numerical variables mean something. Okay. So once you've gotten this in Excel, we'll later show how to do this. You can now talk about it. The mean. Whenever the mean is bigger than the standard deviation, it means that the data are closer to each other. When the mean is very, very below, or when the mean is below the standard deviation, when the standard deviation is bigger than the mean, it means that there's a lot of variability among the data. So it means that the quantity demanded of each store is big among the variables. Some of them have got big quantity demanded. Some of them have got small quantity demanded when the standard deviation is bigger than the mean. And when the standard deviation is, what do you call it? When the standard deviation is 0, who can tell me what does that mean? When the standard deviation is 0, what does that mean? When the standard deviation is 0, what does that mean? You guys have been hearing these words a lot. Today I'm digging them further. When the standard deviation is 0, Ima?
Doc, it means that the values are the same.
Exactly. It means that they all have the same value. It means that if the mean is 170, all of them will have 175, 175, 175, 175, 175.
Doc, I believe that the rate contribution will also come with some marks.
It always does.
Thank you.
It always
I'm okay.
does.
Doc, I'm
There's
okay.
10 marks allocation for that. Yeah. I didn't want to ever say it, but it's because you brought it. I didn't want to ever say it. You have gotten a lot of marks last week already. Anyway.
Yes, Doc. Thank you very much.
So a lot of the values have got the same things here. And that is the key point in there. The other ketosis skewness, all of these are all talking about the range, the dispersion, the dispersion from the center. But then the key one is the mean and the median for major factors. Now, the next thing after you've checked this is to go ahead and so you've generated your descriptive data and then comment on them. We've done it in Excel. And everything that I did, I've given you the solution. Now let's do it in R. So go to your R, and this time, because we are doing it in R, you need to load the Brukutu for R sheet, this one, the one that contains English letters. So you're going to load this one here. So I'm going to do Control A to highlight everything, Control C to copy, go to your R Studio. And now I'm at R Studio. I'm going to load the data and I'm calling it Gen. Guys, which one of you have written all the codes into R already? Show by hands if you have typed all the codes.
Yeah.
Show by hands if you have typed all the codes already into R. Don't force to raise your hand if you haven't done it, because I'll find out right now. Okay, so 3 people have done it. Gladstone, you have done it.
Yes, Doc. Yes, please.
Now, why is it that the 2 other people stop moving? Please show your hand. Don't lower it. Keep showing the hand. Because it's like all of a sudden, people are stopping their hand raising. If you have typed all the codes in the slides into your work, show by hands. Okay. Emmanuel, you can show your. No, let me give it to Gladstone. Gladstone, you can share your screen, right?
Hello, Doc. I join on my phone, but I practice on my laptop.
Okay. So you can use your phone to show your laptop so that I see. I verify. Can you? So that I stop, then you show me.
Okay, so please, I'm doing that.
Okay. I need to stop first. So I'll stop. Show me with your phone. Just point it towards your laptop. Let me see the codes you said you've done. I'm going to give, no, you turn the camera the other way around. Like that. Very good. Go to where the commands are. You are showing me the results, but just point it towards where the commands are.
Doc, I don't know if it's coming properly. I think.
Yeah, it's showing.
So please, the commands are here.
Yeah. Okay, you've done some of them, not all of them, isn't it? Oh, you've done some of them.
I think it's some. Yes.
Yeah, good. At least you've done something. You've done something. Where is my class rep? Are my class reps here? Or today chose not to come? Are the class reps here? Emily.
Doc.
Okay, please write this name down. Gladstone. Gladstone, what's your full name?
Doc, please, is Gladstone Ahaji.
Emily, his name is here. Write his name down for me.
Okay.
Who else has his commands to show me? Who else? Oh, quickly.
Doc myself. Doc myself.
Okay, show me.
I'm sharing.
Yeah, share quickly. I can imagine how someone would be so much rushing to just do all of this. That's why it's okay. You are advanced. You are more than everyone. It's okay. You are a serious person. I think you are the only serious person I know in this class. Let's go. It's okay.
Thank you, God. Thank you, God.
You've done the thing so beautifully. I don't even know. All right, Abo, show me. Please, if you have done it, raise your hand. It's not like you're going to raise your hand later. Abo, you never raise your hand. All of a sudden, you're raising your hand. What is that for? Huh?
Doc, yes, I've done it, so I'm trying to share it now.
Hello.
Yeah, but why is it that earlier on when I asked people should raise their hand, you didn't raise, and all of a sudden you're doing it?
Oh, I thought I had. Sorry.
You thought? You mean you are raising your hand? You know you have raised your hand when you haven't.
Doc, please, the name of the second guy.
Doc,
he's called Emmanuel.
I'm Emmanuel
Osebos.
So
Joseph, I'm waiting for you. You see how Emmanuel quickly showed when I asked him?
Yes.
So be fast for me. Go down.
I have to go down? Okay.
Where did you get this?
Come again?
Did you get this from the slides?
Yes.
But the slides, I never wrote BP.
No, the BP is the assignment. The assignment to give us the
Okay.
blood pressure.
So where is the one for the slide? Where is the gene? Where is the gene one? Go to the left. Go to the left of this thing. Where is the gene? Where is the command for gene? Did you type the one for the regression, the gene? No, you didn't. You didn't. It's okay. You stop sharing your screen. You didn't have. You didn't have. Close. Okay. So it's only that's why you didn't actually show your hands earlier, like I said. So Emily, those two people. Okay,
yes, Doc.
There were three of them, but I think one dropped out because the person realized that he's not done it. Anyway, so only two people did that. Perfect. So Emily, please document those names and put 5 marks there for me.
Okay.
Reward those people.
Look, I'm the other person, but I just did only one, so that's why I dropped my hand.
Yeah, it's better you dropped. It's okay. I understand. Yeah. I understand. Put 5 marks there for me for those two guys.
Yes, Doc.
Because if I can go ahead and type all of these, and then yours is just to, just duplicate what I have done, and you are not able to duplicate, then don't worry, then you can do it later. All right. Samson, what is it?
Yes, Prof, I was the one that sent you a private message yesterday requesting your help, given that I had problems the other day when I shared my screen. So I lost everything, and it
Don't
was
worry,
one
we can
of
talk
my.
about that later. Don't worry.
Okay. No, I'm trying to say that, sir. I'm trying to say that why I couldn't do this one
There's
is
no
that.
need to explain that why here.
Okay.
Because that's a personal problem you had, isn't it?
Yes, sir. Yes.
Yeah, it's a personal problem. So if you bring it in a public domain, you are like everybody will have. My mother also died, and my house was burnt, and my laptop was gone. There's so many things. All right. So we've copied the data. Come to Jen, and since you have the slides, you can copy these things and run the data here. When you run the data, it comes down at the bottom. Okay. The summary statistics that we did, you can show it in the first command here. Okay. This first command. Now, if you check the slides, okay, I have that same summary gene here. I have it here. If you want to see the whole data set, by now you should know that you can type head and type head. And that will show you the first 6 rows of the data. You can always do that. And at the bottom here, you can see that it is showing the first 6 rows of the data. All right. Now, if you want the summary, which is in the slide, which I did in Excel, you can run this command. Now, in this command, well, let me do it again so that it will look better. In this command, you will see that the summary is here. There's something beautiful about R, which Excel didn't do. Remember that Excel, it gave you numbers for the dummy variables, but with decimals and telling you even descriptive statistics. The good thing about R is that it doesn't do that. It rather tells you that they are characters. Okay, it tells you that they are characters, which means that the reason why it will not give you their summary statistics. That's it. But then this command called summary gen, it doesn't give you all the summary statistics you need. It doesn't. It only gives you the minimum, the maximum, the first quartile, the third quartile, the mean, and then the median. That's all it does. That's all. It doesn't give you much. So usually, if you want more information, you don't use this. Okay? You use something else, but we'll come to that something else. We'll come to that something else. Now, that's something else. Okay, let me bring that something else before we go to the next command. That's something else. To do that, that's something else. You need to require a package. And the name of the package is called require psych. The package is called psych. You've used it before. So run this command package. First, you have to install a package. And after installing, you run this package. Because you have written the codes, you're going to run it. And I'm sure you know that anytime you have require and library, it means you have to run. You have to install. So let's run the package. I just did. And then now choose the next command called describe gen. This one.
Yeah, bro. Please, why do we call this data set gen instead of the Brukutu?
The reason why I called it Jane is because I wanted to use that name. In fact, I could have used any name. And the shorter the name, the better. So I could have used Jane. It's even better. But for this one, in the early days when I did it, I used Jane. And it's shorter than Brukutu.
Okay, so like, do I have to inform R that I'm using Jane instead of Brukutu or something?
No, once you write that, just continue using that, whatever you are talking about this. So you can see that the next command, I wrote head of Jane. I didn't write head of Jane. When you use,
I don't know whether, please, I don't know whether because I'm using a MacBook or something, but whenever I key in the code Jane read.delim clipboard or something, it doesn't come. I have to go to file and load the data and attach the file.
Yes, Derek.
I've had that problem since day one.
Derek,
yes, it's the same with me, a Mac user. So you go by the approach of the file. So usually when you use delim, it doesn't work. So you need to load it through the file, and then when it's loaded and you see it on your extreme right-hand side, then you go ahead without using the delim, it will work. So you avoid the first step that Doc has written, and then continue from downwards. That one will work for you.
Yeah, what happens is that if we go through that process, then we cannot use the gene because the data is recognized as Brukutu. Or
yes. So you use Brukutu,
no,
or you
so
can
that
read.
means that you need to rather save the data as Jane.
Yes.
Excel file. Okay. Save it as Jane before you run it.
Yes.
Okay. All right. Okay, that would make sense.
So go and rename it as Jane and then proceed from there.
Thank you, Prof.
All right. Now, once you have done the require, you can now use describe to get more descriptive statistics. And there you go.
No, mine is saying that it is loading.
Oh,
is it
forget.
okay?
If it's loading, continue.
Okay, sir.
Mine
Okay,
also
sir.
said it's loading, as you may see.
Required. Okay.
Once you have done the descriptive, you are able to get more descriptive statistics here. But look at the last one. It has starred them. Who can tell me why they have been starred? Why have they been starred? Samson.
It's because they are dummy variables.
Good. So what R is actually telling you is that don't focus that much on them. Okay. All right. So you have your descriptors, so you can just talk about them the way you want. Another command you can now deal with is if you want to describe or want to generate a contingency table. Guys, this command, you may not have it in your notes, so you may have to type. This command 183 I have here. You have to install a package called library mass. Okay. Like I said, you may not have it in yours. Oh, and by the way, some of you, when you do library describe gen, did it work? Those of you who have done the describe gen, did it work?
Yeah,
Doc,
okay,
it
work
worked.
from my end.
All right. Now, to be able to go to, so the next thing is to install and then invoke the library mass here. Once you install and invoke the library mass, once you install and you invoke it, you can now do something we call attach. In fact, you have to do the attach before you come to the next thing I'm going to talk about. If you don't do attach, the rest of the information might not work. Other than that, okay, don't do attach, don't do attach. Don't do attach. Just run the library mass. Guys, I hope you know the difference between when you're attaching and when you're not attaching. Okay. So if you want to generate a contingency table, I want to generate a contingency table between religion, occupation, and location. That's what I have here. This command. It's just to tell me the diversities, the contingency table. So you can create a contingency table. We did this thing the last time. I'm just typing create a contingency table. And you can see that I wrote Jane dollar religion. So I wrote Jane dollar before the name of the variable. Okay. Then I wrote Jane dollar, OCC, Jane dollar. Now I bring Jane dollar all the time when I'm picking a variable. But if you don't want to pick the variable, you have to attach. And remember to detach. When you attach, you don't add the dollar, the Jane dollar, the Jane dollar, the Jane dollar, anytime you are mentioning a variable. But for this very one, I have not attached, so I'm using Jane dollar, Jane dollar, Jane dollar. All right. So do that, and then that will give you a contingency table, as you can see down here. So do table into bracket Jane dollar religion, Jane dollar occupation, Jane dollar location. And when you do that, this is what you get. It classifies each of them across religious groups, across occupation, and across location. So you can see from here that among the rural folks, 8 of them were Buddhist. Among the rural folks, 8 of them were Buddhist. And out of that 8, only 4 were fishers. And among the urban folks, okay, 8 of them were teachers. 8 of them were teachers, whereas 12 of them were fishers. And among those fishers, only 8 were Christians. So this gives you dynamics of the data. Okay. Like I said, don't use the attach. And remember, anytime you use attach, you have to later detach before you close your R. Anytime you use your attach, you have to do detach before you close your R. Don't forget that. I just typed that there. Now remember to detach before you close. Yes, someone.
Please, what will happen if you don't detach?
If you don't detach, it will keep those things in its memory. Next time you come, next time you come and you use something, it will use this one when you are not even using this data or something else. It will still think that this data is what you used. It will mask. It will mask.
Thank you. Okay. Understood. Thank you.
All right. So,
Doc, last question. What happens if you copied a wrong data and you want to run it again? Do you need to copy the right data and go to the first step of loading and it will replace the old one?
When you say you copy a wrong data, why are you saying wrong?
Here we have two separate data in Excel worksheet, one with the R and one with the coded and the one to be using the R.
You know that anytime you are doing the R, the data you are going to choose is the for R.
Yeah.
So you shouldn't even think about, I made a mistake in copying that. Yeah, if you made a mistake, go back and copy the correct one and bring it back again and start all again.
Okay, sir. Okay, I'm okay. Okay, Doc. Thank you very much.
And by the way, when you are starting all over again, you don't need to go through all over. You can just highlight everything all like this, all at a go. Now run. They will all start populating at the bottom. Okay. So now,
thank you very much. Thank you very much.
Now let's go to describe. I've just done that of the describe. I've explained it here. You can also describe by group. I've said this in the last time. For example, you might want to know among here, you might want to know, and you got it, guys, if you, the last time some of you were saying that you didn't have some of the codes. Okay. I don't know, but if you don't have some of the codes, don't worry. I can always put it here for you, which I just did. I'll put it in your page for you, for the codes that you may not have. If you want to describe by group, let's say that among the religious group, you want to know their descriptive statistics. Like you want to know how many of the religions, the quantity demanded of the Christians, the quantity demanded of the Muslims, and then for the Buddhists. You can run this command. Then you can do that. So you can see that the result is showing clearly down here that the Buddhists are 12. The sample size shows that they are 12. And then the Christians are also 12. The sample size are shown. But then the Muslims are 16. The sample size is showing that they are 16. Then in terms of mean, the quantity demanded for the Buddhist is 180 bottles. The quantity demanded for the Christians, not bottles, but in terms of quantity, is 206. Okay. And then the quantity demanded for the Muslim is 147. So just by looking at the mean, you see that the Christians are consuming more of that akpeteshi than the other group, religious group. It gives you a feel of the data. You can also group them according to occupation. Okay, I just did that for the next command. In the occupation one, as you can see, you notice that the fishes are 16 and the quantity demanded is 205. The teachers are 12, the quantity demanded are 170, and the traders are 12, the quantity demanded are 140. So you can see that the fishers are consuming more. So akpeteship are more by the fishermen, fisher folks. They are consuming more. So this will give you a bit of the descriptive analysis. This is when you have groups in your data. You can use this group analysis a lot. Okay, any question on that? Now, you are going to generate some graphs. Okay, so how do you generate graphs? You can put all graphs together. We did it the last time. Okay. You can put all graphs in one. I'm going to generate a histogram, a kernel density, a normality, a box plot. This thing we've done already, so I'm going to go fast here. I want the graphs all to be together. You can put two graphs together. If you want two graphs, you can do two. If you want only two graphs, you can do 1, 2. That is left, right. Or you can do 2, 1. That is top, down. But if you do 2, 2, you have left to right again. You know, and that is how this command will look like. So I'm going to do that. I'm removing the attachment. And I'm going to run this command to indicate I put the graph. And guys, you can see this whole thing in your slides here. So I'm going to run all of these graphs for them. This first command will give me 4 space to put a graph. The first one is a histogram, that is here. Second one is a density, that is there. Third one is a quantile normal probability plot, that is here. The last one is a box plot, that is here. And at the box plot, I did a box plot according to occupation. You can do a box plot according to different. In fact, the box plot, the color, I made it purple, but I can just say rainbow. Let me write it. I can do rainbow and do 7. If I should change that, the whole thing will go back again. Yeah, it's gone back. Anyway, now that is how it is. Okay, so these ones are the graphs that you can have. What I'm just trying to say is I can always edit some few things. So this is it, and you can put all of this graph in your work. In your major assignment, I will let you do this. You can also test the normality of the data. You can test whether quantity demanded of gene bitters is normally distributed. And we did that for empty class, so I know you know. We did that for empty class, so I know you know. So you can test for that. Some of you say that, oh, you didn't give us that command. Well, it's there. So I've also given you that in case you need it. That's it. And in this case, when I did it, you can see that the p-value down here is 0 approximately, which means that quantity demanded is not normally distributed. We are done. Let's go to correlation. Correlation. Now, when you want to do correlation, you need to use the coded data. But we have already seen that, and listen carefully, we've already seen that dummy variables are not needed when you are doing descriptive statistics or correlation. So what I'm going to do is I'm not going to use this command, and you guys have it here. Okay. You can do the correlation in Excel. Okay. I had you do it in Excel. Let me quickly show that. I don't normally like using it, but the Excel, you cannot use the coded. Sorry, you cannot use the Brukutu or R data, the one that contains true letters. You can't use this. So you have to use the coded one here. How do you do correlation? That means you have to code it first, by the way. Go to the data tab at the top and choose data analysis. In the list, you see correlation. Just double click. And then the correlation box will appear, parameter dialog box. Highlight everything in the data. Okay. And then put it there. And then take the labels in first row, take the output, and indicate where you want your output to be. I want my output to be just right below the descriptive statistics. And click OK. And boom, you get this beautiful correlation matrix. It's nice. On the top, click on the Home tab, and under General here, click on General and choose Number. When you choose number, everything will be in 2 decimal places, like that. And once you do that, you will get what you have in the note that you have. So this is a whole correlation matrix. This is what you will bring into your work. Let me tell you what 2 disadvantages of the Excel one is that it will not give you p-values. But the way it looks is beautiful. It's more beautiful than the one you might get in R. Python is even better because Python will give you something called heat map, and it will add colors to it so that you can quickly identify the intensity of the correlation. But it's also Python also struggles to give you the p-values. You have to run that slightly separately. So R is very good when it comes to doing correlation. And then you use Excel to confirm if you don't have a lot of numerical variables, a lot of categorical variables. Because mind you, these categorical variables you are seeing here, they are really, really not important. Okay? They are not that meaningful. Dummy variables or categorical variables are not that meaningful when it comes to correlation. Let's take a look. And I've asked you questions. Okay, so I've done this thing in Excel. Now let me go to the R. Okay. So if you follow the rules, you'll get this thing in Excel. And we can do the same thing in R before we come to the questions. So how do you do it in R? In your slides, when you scroll down, you see the one that was done in R. Yeah. This command will give it to you. So let me quickly show you how to do it in R. Don't use the code. You can do the coded one, but like I said, it's not the best. So use this command. You have it in your. This command will remove all the categorical variables from the data set. And you have this command here. You have it here, the last bulleted point. It will remove all the categorical variables. So what I'm saying here is I want you to run the correlation gene, but I'll minus which. So which one should I remove? Which one should I minus? Minus LOC, OCC, RE. You're going to run that. You can use this pairs to get the correlation, the scatter plot matrix. I'll do both. That'll be it for today. So one, this is a correlation. You see, it has given me only the numerical variables. The decimals are too many, so I will change it very soon. So this command, round, we put it in 2 decimals. And again, in your notes, you should have it. Yes, you have the one for the round. When you round it, okay, so this round, oh, sorry, it's here. You need to round this one, I just did, and you can see that it gives you the correlation. It's not as beautiful as the Excel, but at least you have it in 2 decimal places and all. And more importantly, you can generate the scatter plot matrix by removing the dummies. I did that. In fact, before I do that, the graph is going to give it to me in this format. So I don't want the graph to be small. So let me run it and let's see. Okay, the graph is small. Yes, somewhat. Your hand is up.
Doc, please, you mentioned that the difference between Excel and R is that R gives you the p-values.
R gives you the p-values. Excel does not give you p-values, but Excel is more beautiful than R.
Yeah, so please, where do we?
I'm about to do that.
Okay.
I'm about to give you the p-values. That's the last thing I'll do. Okay, so note that this pairs, this scatter plot matrix gives you a scatter plot of each variable. And I'll focus on the numerical variables here and how each one of them is related with a dependent variable, which we'll talk about better next time. Now, the correlation here is great, but it doesn't give you the p-value, so we are not going to generate the p-value. That one is better than the correlation because the p-values will come with also the correlation. To do that, you need to install this package and invoke this package called library H miscellaneous, which we have done already. Library H miscellaneous. So when you go here in your slides, you have it in your slides here, library H miscellaneous. Then you run the correlation and remove the numerical variables. That's what I'm focusing on. I'm doing that, run the library miscellaneous, and then run the one that you remove. And I just doing that one, and look down here, you get a perfect result. And this is the last result I'm showing for today. Now, let me tell you something about this result. What makes it interesting is that at the top, it gives you the correlation. The last columns here are not important, so you can always remove. Then at the down, it gives you the p-values. The p-values here are simply 0, 0, 0, 0, 0. That's what it means. What you are seeing here means they are 0, 0, 0, 0, 0, 0. But how do you read each p-value? If you pick P versus Q, okay? So when you check here, this is P versus Q, the correlation between P and Q, negative 0.87. Its P value is this one here, which is 0. The next one is 0.72. Its P value is the one down here. The next one is 0.761. Its P value is the one down here. Okay. The next one on this side, because remember, all of these sides here, everything on this side is not needed. That is the one Excel cutoff in the Excel one. So let's go to the next one. The next one here, which is negative 0.74. Its P value is this one, 0. The next one is negative 0.51. Okay. Its P value is this. So all of them, the P values are almost 0, 0, 0, 0, which means that the correlations are significant. They are significant. They are significant. They are significant. That is how you read the P value. Anytime the P value is less than 5%, it means that a correlation is statistically significant. So that is where we will end this one, but you should be able to read the correlation. Okay, you should be able to read the correlation coefficient. So I'm going back here in the slides and show you something tiny, how to do the correlation. So look here. This is a correlation matrix, the one you can see here. There are some few things I want you to take note before you go. This is an entire correlation matrix, the one you saw in Excel. Don't worry, even though I'm showing you this, I've already told you that anything here is not that important because they are all the dummy variables. Okay, but I can ask you some questions. And one of the first questions I normally ask is, what is the correlation between C and P? Who can tell me, looking at this result, what is the correlation coefficient between C and P? You should be able to learn how to read correlations. What is the value?
Say negative 0.74.
Very good. Negative 0.74. What is the correlation coefficient between M and C? M and C, decimal.
Bro, 0.71.
Good. What about RC and RM? RC and RM. I know I said we don't normally focus on dummy ones, but at least tell me the coefficient, Noah.
Prof, negative 0.53.
Good. So you should learn how to read correlation. Next one, before we go. Which three pairs of variables are perfectly correlated? Perfectly. Three pairs. Three pairs of variables that are perfectly correlated. Three pairs of variables that are perfectly correlated are those that have a correlation coefficient of 1. Emmanuel. Q and Q is 1. P and P is another. C and C is another. M and M is another. And the rest continues like that. That's what we mean by perfect. Perfect means they have a correlation coefficient of 1. Next question. Which two pairs of variables are strongly correlated with the response variable? By the way, who can tell me what the response variable is here? Which is a response variable? Samson.
I think it's a Q, the quantity demanded.
It is a Q. Which variable is highly correlated with it? First, the most one, Noah. Noah. Noah, we can't hear you.
Doc P.
P. Very good. What's the value?
P, Doc.
What is the value?
Negative 0.8.
Negative 0.87.
Which is the least correlated?
OT, sir.
It's not OT. Okay, you are taking the dummies as well. Okay, good.
Yes.
You are taking the dummies, yes. Negative
Yes.
0.11. Very good. You should be able to know how to read. Now, last question for today. Which three pairs of variables are mostly multicollinear? Let me talk about just the first pair. Mostly multicollinear. By the way, a multicollinear variable does not include the dependent variable column. It includes every other thing except the dependent variable. It is two independent variables that are highly correlated. We'll talk about multicollinearity properly next time. But two independent variables that are highly correlated. So you focus on this area and look for the highest number. Which one is the highest? Thompson.
Between M and C.
Correct. What's the value?
The value is 0.71.
That's wrong. Who can tell me the highest? This one.
Yeah, Prof. To be minus 0.74 between P and C.
That's wrong. Who can tell me the highest?
Sorry. Between P and OTR. That's 0.76.
See life. Always open your eyes and look at your things.
Okay, Doc.
Ladies and gentlemen, that brings us to the end of the entire caboodle for today. So next time we shall start the basics of regression. Everything you need to know. And in your thesis, you will need about 4 of the things that we have done today. In your paper that you're even writing, you need that. So you've done a lot of great things, especially the correlation with the p-values. Learn. Any question? Any question at all?